Spherical particles of given material of density rho are released from rest inside a liquid medium of lower density. The viscous drag force may be approximated by the Stokes law, where eta is equal to the viscosity of the medium and r is the radius of the particle and v its instantaneous velocity. Now, if tau of m is the time taken by the particle of mass m to reach half its terminal velocity, then the ratio of the tau of 8 of m to tau of m is what? So we'll start with the problem by solving the Newton's equation. So we have F is equal to ma. Here we have the viscous force. It's acting opposite to the direction of the motion. So I write it with the minus sign. So the viscous force is given by Stokes law. And acceleration I write as dv by dt. Now immediately this can be solved, this differential equation can be solved to give the velocity. So I will use the separation of variables method. So we can rearrange the equation this way: dv by v is equal to so this is the differential equation. Now when you integrate both sides, so just if you just integrate both sides, you will get ln of b minus 6. So this can now be taking the so take exponentials on both sides, the exponent e. So we take that. Now this will get raised to the power e. And multiplied by a constant. So let's call this constant c. So this is what we have. Now we are told that for mass m, the value of half its terminal velocity. So we are told in this question that for particle of mass m, the time it takes to reach, okay, is tau. The time it takes to reach half its terminal velocity is tau. So I'll write an equation describing this. So v by 2, half its terminal velocity is reached by the particle so it's reached by a particle with radius r1 at a time tau 1. Okay, so for mass m1. And for a mass of 8m, so for a mass of 8m, it reaches at, so this is for mass m and this is for mass 8m. So it reaches half its terminal velocity at, so we don't know the radius, we take it as r2, and reaches at time tau 2. Now this is m2, we evaluate the mass. So now let's divide the above equation. Now these two equations, let us divide. So when we divide, we'll get r1 by m1 tau 1 is equal to r2 by m2 tau 2. So this tau 1 by tau 2 is what we are asked to evaluate, right? So we are asked to find the expression for tau 2 by tau 1. So tau 2 is 8m, tau 1 is m. Okay, so now what we're going to do is we're going to use this equation. Let me do it on the side of the board. So we know m1. So m1 is nothing but 4 by 3 pi r1 cubed. Density is the same. So density is the same. This is the mass m, right? This is the mass m. So the volume multiplied by density. This is the mass m. Now, what is 8 times m? 8 times m is the second particle with radius r2, same density, and this is m2. This is what we've taken as m2, right? So now let's divide these two equations and get a relationship between m1 and m2. So so we divide these two equations, we'll get m by 8m is equal to r1 cubed by r2 cubed. So from this we get that r2 is equal to, so r2 is equal to 2r1. So let's substitute all this here. So we can just substitute all this here. So m1 is nothing but m, and m2 is nothing but 8m. So now we're going to find the relationship that has been asked. So this is m, this is 8m. So r2, we are told, so r2 by r1 is nothing but, from this equation you can tell that is nothing but 2 by 1. Okay, so we just solve this now. When we solve this, we get tau 2 by tau 1 is nothing but 8 by 2, or is nothing but 4. So this is your answer. So the right option here is given by option C.